Hey guys, so we got an equation here. How do we solve for this x? First, I'm going to recognize that this 6 is 2 times 3 and copy everything else down. So I can get rid of these 3's very easily by dividing both sides by 3. So the 3 is now gone, and I'm going to copy both these down. I'm going to put parentheses around the 4 and the 8. Now I look at the 2, the 4, and the 8. I'm going to rewrite them all with a base of 2. So let's copy down the parentheses. This 4 I'm going to express as 2 squared, and this 8 is 2 cubed, because 2 times 2 times 2 is equal to 8. And this 2 I'm going to make it 2 to the 1. Now let's bring down everything else. Now we have 2 to the 1 times, and then this, we can multiply these exponents. So this is going to be 2 to the 4x. And then for the right-hand side, we can also multiply these. So 3 times 3x is 9x, and 3 times negative 1 is negative 3. On the left-hand side, these both have a base of 2, so we can add the exponents. So we end up with 2 to the power of 4x plus 1. And on the right-hand side, we still have 2 to the 9x minus 3. Now, since both these have the same base of 2, the only way they're going to be equal is if these exponents are equal. Or in other words, we can drop the base. So we end up with 4x plus 1 equals 9x minus 3. I want to get this x to the other side, so I'm going to subtract 4x from both sides. And I want to get the x's alone on this side, so I'm going to add 3 to both sides. 4x minus 4x goes away, 1 plus 3 is 4. And then 9x minus 4x is 5x, and negative 3 plus 3 goes away. I want the x by itself, so I'm going to divide both sides by 5. And I get x is equal to 4/5, and that is the answer to the question. This is how to solve these equations. Anytime you have these, you want to try to get them all to have the same base, so then you can just do stuff with the exponents. And the tricky part here was that we had the extra 3 in here, but that was easy to get rid of. How exciting.